Good evening to everyone. Thanks for everyone joining this event in this pleasant evening. We are very glad to have all of you in this very valuable presentation given by Engineer Bandala Subasinger. In a minute, I will start the formal way of giving the addressing and we will start from there. My name is Sodhi. I am from IESL NSW chapter. And some other people from New South Wales also has joined here. So welcome everyone. All right, let's start the meeting formally. Good evening to Engineer Bandala Subasinger, IESL committee members and fellow engineers. Let me start the meeting with acknowledging the traditional landowners as our tradition. In spirit of reconciliation, the IESL NSW chapter acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander people today. First of all, let me thank Engineer Bandala Subasinger for accepting our chapter's request and delivering this valuable lecture for our members. It is the time now and privilege to introduce Engineer Bandala Subasinger to our audience. Bandala Subasinger obtained her engineering degree with honors in electrical engineering from University of Moratuwa in 2003. Bandala is a chartered professional engineer in the area of practice electrical and building services with Engineers Australia and Institution of Engineers Sri Lanka as well. Bandala has over 17 years of experience in the building services consultancy, design management, project management, and technical review roles across various residential and industrial building design. Bandala is passionate to deliver emerging sustainability strategies for new and existing buildings through well-coordinated, energy-efficient electrical design that meets global standards and project objectives. Her extensive technical skills include electrification of building, whole life carbon approaches, climate resilience, energy and sustainability master plans. Bandala is managing the ARUP's Global Electrical Network, All Electric Building Design Working Group, connecting key electrical services representatives from all Arab region, including USA, Canada, UK, and Singapore. In her global team, she is responsible to develop a design and client information pack to design buildings with regards to power demand estimation, spectacle planning, and implementation of technologies such as on-site power generation and on-site power storage. Today's presentation topic is Sustainable Design Consideration for Electrical System in Building Design. Let us welcome Engineer Bandala Subasinger to deliver her valuable presentation. Welcome, Bandala.
I hope you all can hear me. Thanks for the lovely introduction, Soti, and thank you IESL New South Wales chapter for inviting me to deliver this presentation and on the sustainable design considerations for electrical systems in buildings. First of all, I would like to pay my respect to traditional custodians of this land we meet, and I pay my respect to the elders, both past and present. And I would like to thank all who has joined today, because I didn't really expect this much of crowds to join the meeting today. Thank you all for joining, and I would expect that we would be able to have a really good discussion at the end of this presentation. So throughout my presentation, I'm going to give a little brief introduction about myself and my career path, how I came here, and from where I started, and we can have a good discussions about climate resilience and adaptation, sustainability development goals, which we are globally trying to reach, and net zero carbon emission decarbonization and ESD tools, which we are using in Australia, and how we are implementing full electric buildings design to meet this global sustainability development goals. And finally, if we have enough time, I'll share a couple of projects which we have already implemented with this full electric building design concepts. So as Soti mentioned, I graduated from University of Moratuwa in 2003, and soon after, I joined the electrical engineering department as a tutor for a couple of months, and then I don't really remember how my resume went to DCL, Design Consortium Limited in Colombo. Somehow, when I ended up at the interview with Dr. Nalin Vijaykorn, I haven't had any idea what is building services. Because there's no subject called building services in electrical engineering studies. So I haven't had any idea what is building services and what it holds for me when I joined it, because most of our colleagues from my batch, they joined CEB, and some people joined Virtues as IT consultants as well. So I was wondering like what this holds for me, and luckily I got through the interview, and I got the opportunity to work with this amazing two senior engineers, which I always remind with respect, Engineer P. Somaratne and Engineer Uday Karunaratne, who gave me the foundation for my building services career as a building services consultant engineers. I would like to thank both of them for all the supports they have given me. And in 2007, I got married and went to USA with my husband Pamal. And soon after we went to USA, I wasn't expect that I would be able to find a job, because I just had 3 years experience at DCL Building Services Consultancy. Somehow, luckily, I on the second day, I got a call from one of the leading building services companies in Massachusetts, and I was lucky enough to join Hard Companies, Hard Design Group, as a graduate young electrical design engineer. And I worked there for about 2 years, and my company tried to get visa to stay in USA, but I didn't get through the visa process, which we have to go through the lottery system, unlike in Australia. So finally we have decided to come to Australia, and I worked in Melbourne and Sydney for almost 12 years now, and yes, still enjoying building services, and it's a great field of area for electrical engineers, especially women engineers, to explore and stay in. So I thought to share some of the projects which I have worked on past. This Celestial Tower building is a is the first project which I have worked on as a building services consultant at Design Consortium Limited with Mr. Somaratna and Mr. Karunaratna. So that really gave me the foundation for the building services. When we were doing this building, I got the opportunity to do not only electrical, but hydraulic services and mechanical services as well. So that foundation about like whole of building services gave me the opportunity to work everywhere, anywhere within the world, to understand the building services concepts and standards which we are currently designing. So it's that project, I never forget that. It's a 80-story building. It was supposed to be built like as the tallest building within Sri Lanka during the time. With the 16-story Hyatt Regency hotel at the lower level, and rest of the levels with residential and commercial towers. And this cell culture expansion project in Massachusetts, it's another pharmaceutical project which I've worked on in the USA, and that's the off-country project which I worked as a first offshore country project. And then then I worked on different projects which I'm really proud of, where I am and what I'm doing. These are some of my recent projects, maybe like just looking at some of these projects, you probably know like what are these, and I'm really proud to say that I was a big part of all these projects, and I was leading the electrical design for this first high-rise school in Sydney, and the new Museum of Applied Arts and Science, Powerhouse Museum in Parramatta, and a few other hospital buildings which I haven't really mentioned here. So I'm showing these projects not to boast, but to encourage our young engineers who are kind of stepping into the engineering world to consider joining the building services. So you don't have to do only electrical engineering. If you're doing mechanical, hydraulics, civil, any type of engineering, it's a path which you can choose. And within Arup, we have graduate programs as well. If you want to join any of our teams, just feel free to reach out to me. So let's move on to the climate resilience and adaptations, the main topic of our, I'm sorry, of the building. So the climate resilience and adaptation. So when we talk about the climate changes which we are experiencing now, the first thing we have to understand is the GHG emission, which is the greenhouse gas emission and the carbon footprint. So due to our actions, we are emitting, knowingly or unknowingly, we are emitting a lot of carbon dioxide to the environment. So this carbon emission is scoped under 3 different sections. Scope 1, which is direct emissions, and scope 2, indirect emissions, and scope 3 again, 2 and 3 both indirect emissions. I will go through this carbon emission scopes later in this presentation. So we probably, like we all know that the climate changes is already happening, and the temperature rise, like each year we are experiencing about 0.3% centigrade increase in temperature. So that's why we are experiencing a lot of adverse weather conditions, such as extended droughts and a lot of intensity of extreme rainfall events and things like that. So when we are designing the buildings, we have to now, since we are designing the building, we have to expect that the climate will change, and these severe weather conditions can be worse than what we are experiencing now. So when we are designing the building, assessment of risk assessment of this climate resilience is very important. And implementing the building designs to cater for like safety of the people, safety of the buildings, we have to cater the design and implement the safety measures to do that. So when we are doing a project, we always do the risk assessment to see how what are the implementations which we have to incorporate it to the building. So say, for example, we have to assess the fire issues, fire safety issues because of the bushfires very prone in Australia, and flood issues, and few different climate related issues, so that we can implement designs to mitigate those risks associated with climate changes. As I mentioned, I would like to go a bit deep into the greenhouse gas emission and defining the different types of scope of carbon dioxide scopes. So the scope 1 are direct emissions from sources that are owned or controlled by individuals. That means the scope 1 emissions are directly related to us, directly related to what we do as day to day. Like when we use fuel combustion and fleet fuel consumption, using gas, petrol, and all these things are associated with scope 1. And scope 2 are indirect emissions from sources that are owned or controlled by the agency. Sorry, I forgot to mention, if you have any questions, feel free to post it in the chat so that we can have a discussion at the end of the presentation. Sorry, going back to here. So scope 2 emissions are indirect emissions from sources that are owned or controlled by the agency. That means scope 2 are when we run air conditioner or something, like we need to get power from the grid. We need to heat the hot water heating. We need to get gas from the street network. So the indirect emission from those transmission from heating, like which we are using heating, cooling, that is scope 2 emissions. And scope 3 emissions are from sources not owned or directly controlled by the company, but related to their activities, such as employee commuting, business air travels, contracted solid waste, like how we dispose the solid waste and waste treatment, etc. So when we are considering the scopes of gas emissions, with to meet the path of global targets of net zero gas carbon emission, we have to consider how we can reach the net zero scope 1, 2, 3 emissions. The hardest part is scope 2 because it's associated with the national grid. So most both in Sri Lanka and Australia, our not in Sri Lanka actually, we have a lot very strong biomass and hydro base load, and we are only 30-40% of the power generation is through petroleum systems. But in Australia, most of our power generation through coal power plants. So greening the grid would be a big challenge for us. But however, we have in our 2050 master planning for the greenhouse net zero emissions, which we are targeting as a global initiative. We are planning to meet the reduce the green the grid within 2030 midway target and 2050. So I'll go through those things later in this presentation. And scope 3 emission, again, these the communicating strategies, and when we are there's a way that we can consider reducing the scope 3 emission as well, because reducing the embodied carbon emissions from transportation and distributions, those things with the introduction of this EV, electric vehicle charging, etc., we can consider reducing the scope 3 emission as well. So a combination of all these three, we have to consider how we can go there and meet the global targets of net zero carbon emissions. So when we, so this is kind of a diagram which says that we are not talking about zero carbon emission. We are talking about net zero carbon. It's the that means we can't really design a building with zero carbon, because there's carbon associated with the building development, steel structures, concrete, and everything. The way we can meet the net zero carbon is by offsetting the green, like introducing green power and renewables, offsetting carbon reductions, like there's different ways we can do it. So if you can see my screen, my cursor. So the when we think about the carbon emissions, there's operation carbons, which falls under those three scope categories. And then existing assets will have another level of existing the operation carbons. And when we are developing new assets, there will be steel structures and all these different kind of carbon emissions from the buildings. That's why we are encouraging everyone to install renewable power, green power within their developments. And also there's a method that we can go to the net carbon footprint through getting into a contract with off-site carbon plans. So if you don't have enough roof capacity or roof areas to install green power or PV cells, you can get into a contract with large-scale PV farms to get offset your carbon footprint. And hence, like with that connection, you can consider, like assess your net carbon footprint and reduce the carbon footprint significantly. And as per the information we have, roughly about 80% of the energy-related carbon emissions are from buildings. Out of that, 39% global, 30% from directly from building, and 39% directly from building impact, and the 28% from the operational emission. So 39% from buildings means the structure and the building services and all the other loose furnitures, glass, and everything. And then the 28% of the emission is directly from the operation. So when we run the building, we need to heat the building, we need to cool the building, we need to power the building. So when we do that, there will be carbon emissions from there as well. And the from the materials and construction, there's another 11%. So you can see that the building impact on the energy related carbon emissions. So that's why it is important to consider electrification of buildings and designing the future buildings with that consideration in mind. So with the proposal of greening and reuse recycle arrangement, we have to think about the circular economy. Circular economy is the use of material, either biological, technical, as much as possible from the source where you get it until you can no longer use it or recycle it, and reducing the waste emission as much as possible. So you have to consider using it again and again by recycling it, and reduce the number of waste goes to the landfills. And also dematerializations and substitution are another two main items associated with the circular economy. So say, for example, now we all know that we see a lot of Tesla cars around. So and EV charging stations installed everywhere and things like that. So we are substituting the fossil fuel with the EV charging electric vehicles. So at the same time, this dematerialization and modularization is another a clever, innovative idea. So previously, 10 years ago, you probably have seen large carpets in your bedrooms with like if you spill something, or if it's ripped, you have to remove the whole carpet. But most of the times now they are installing this modularized little carpet tiles, which they can collect together. And if something happened to one tile, they just have to remove one tile and put that in. So that's why I mentioned that innovations and introducing different modularized system and circular economy is very, very important in decarbonization. And so we in Australia, we are planning for 2030 and 2050 master planning and meeting the net zero carbon targets. And it's not an individual commitment. It comes from clients, standards and people who are working on standards and ratings, policy regulators, best practice. And we have to implement all these best practices and come up with a good solution. So as far as I know, that we work together in different capacities to meet these targets within the engineering field, which we should be very proud of. And next, I'm going to talk about the Sustainability Development Goals. And so the United Nations came up, gathered together in 2020 and came up with this Sustainable Development Goals, which is mostly known as UNSDGs. So when we are considering or designing a building, we technically consider all these 17 aspects, but particularly when you're doing the electrical designs, you won't really do all the like no poverty, zero hunger and things like that. But we select, like I have the blue highlighted the areas we generally consider for building designs. So we consider people, we consider well-being of people, we consider the creating sustainable cities and communities, and how we can use the existing assets in a responsible way, and how we can reuse, and implementing clean energy, life on land, and the effect on climate and all those things. So our building designs are basically running around like currently developing through this as UNSDGs, and this is the in collaboration with the UNSDGs, International Energy Agency generated this global net zero carbon roadmap, and this is again something which we follow to the rise of global net zero carbon roadmap. So when we are designing a building, we design the building services, we probably design it for 25 years from now, but the structure needs to be designed for 50 to 75 or 75 to 100 years life cycle. So during that time, even we need to consider redeveloping or refurbishing the building services, but the structures, steel structures, concrete structures, those things will be designed to develop those structures. So since we are designing the future buildings, it is important for us to consider what are the future innovatives which can come into the building services or to the world, and we have to cater for those. So this 2050 target roadmap actually gives us a very clear understanding on what we can do within our buildings. So say, for example, you can see 50% of heating demand met by heat pumps here, but we are actually designing the buildings at the moment with heating demand met by heat pumps. So this is not probably not applicable to Sri Lanka, but in Australia, we are using gas boilers for space heating, and that's the highest gas usage within a building. So that contributes a significant amount of carbon emission to the environment. So we are trying to, for space heating, we are trying to use heat pumps or polyvalent pumps, which we can consider to having both heating and cooling capabilities, so that we still use, for cooling, we still have to use the conventional chiller systems and things like that, because there's no other option. We don't use the gas boilers for the cooling. So it's only for the wintertime power loads. So there's a considerable increase in electrical demand for these buildings. But since it is like, when we have to do different calculations for winter and summer scenarios to understand like what would be the heat loads and what would be the cooling loads in different scenarios. But what I'm trying to say is we are already designing these type of targets at 2020 here. So, and also with the power generation, I understand that like we recently it was announced that we are not approving any new coal-powered power plant, or in improving or increasing the coal-powered power generation. It's going to be like, we are always encouraging people to have solar PV and rooftop solar and large-scale solar farms and wind farms to cater, like in order to get green the network. And also Australia committed to not to import or reduce the import of fuel cars, and increase the percentage of electric cars import to the Australia by 2030. So we all have to get ready to use electric cars in near future, which is exciting and new experience for all of us, I guess. So yeah, it's this map, something which we always reference, and we always try to implement these things. So as I mentioned, again, decarbonization and net zero carbon emissions. So the way electrification, decarbonization, all these things runs around this scope 1, scope 2, or scope 3 emissions. So as I mentioned earlier, zero carbon is like, we don't technically, practically, we can't really meet the zero carbon. We can achieve the zero carbon in relation to our scope 2 emissions if we sourced all our electricity, heat and steam from our own on-site renewable supplies. But most of the times our on-site renewable supplies won't be big enough or sufficient to cater for the total loads. So that's why mostly we are talking about net zero carbon. It's achieved when the carbon emissions are balanced or equalized by an equivalent amount of carbon that is sequestered to or offset. So it's the carbon offset and reducing the carbon emission from the building. And so it's as I mentioned, it's really important that we do the grid decarbonization and electrification of buildings to go through the net zero carbon emission pathway. So the net zero journey is not very simple, but it's not something which we can't do. So when we think about this flow chart, what we need to know is we have to understand what is our mission. Like, when are we planning to design our cities, our buildings net zero by 2030, 2050, or whatever the level. So we have to have that vision. And then what we have to do is we have to understand what is our carbon footprint and where we have inefficiencies and what we can do to reduce the carbon footprint. And then once we understand the carbon footprint from our actions, we have to prioritize the actions. We have to do cost analysis, which we are currently doing. We have to do operational carbon analysis. We have to do number of different things to understand the priorities of the action. So we do all this, all of life cycle costing, the building footprint requirements and things like that. And then that will really help us to program manage the designs. So once we understand the actions and prioritize the actions which we have to consider, we can start thinking about program management, design and delivery, which will really help us to deliver a project with the aim that we are meeting the net zero journey. And when we it won't stop after delivery of the building, which we have to, after that, we have to monitor the outcomes and fine-tune the process again and again to make sure that we are using the circular economy. We are kind of meeting the, maintaining the building to meet that sustainable design initiatives. And through the IEA, International Energy Agency, they have implemented energy efficient solutions, and how we can consider meeting the targets of net zero carbon emission. And through that, they implemented energy efficient solutions, how we can change the building's heating and cooling systems, appliances, and things like that to meet that targets by 2050s. And they have put some targets of, say, for example, here, share of zero carbon ready buildings in total stocks percentage from less than 1% to increase by more than 85%. So likewise, they have developed different strategies for different areas. And this is the graph which they have developed for the electrification of building. So with this one, they have identified how we can implement heat pumps, how we can implement EV charging, and what would be the providing electricity everywhere and reducing the gas. So actually, based on this one, actually we are now designing most of the buildings without even a gas supply to the building. So 10 years ago, we didn't even think about a building without a gas supply. And when we find a house, like as Sri Lankans, we always like to have gas cooktops. So but it would probably change in future, because the new buildings, most of the times, they won't let us have gas connections. So as I mentioned, that the grid decarbonization is a big challenge and a big thing for Australia, and we need to every time when we talk about net zero carbon, people ask us how you can do the how you can green the grid. So yeah, we won't be able to meet the green, totally reach the greening the grid consideration, but we are aiming to increase the clean energy, rooftop energy. So if you look at this one, this is the projection of energy sources, Australia's emission projection. So from 2020 to 23, this is the halfway mark from the roughly 2030 is the usual halfway mark, which we consider for 2050 target. So you can see that there's a significant increase in rooftop PV systems, and the solar and wind energy. Solar means this solar is for the solar farms, not the rooftop. So rooftop and solar together, it's a big portion of the energy. And then we have the wind, hydro. We can't really increase the current capacity. It's very unlikely that we can improve that. And but we are decreasing the coal power generation. So through this pathway, there's targets which we can really achieve the decarbonization of grid. So when we are doing the designs, we discuss about the pathway to net zero carbon from buildings, and understanding the actual carbon footprint, carbon life cycle within a building is very important. So if you look at this graph, so when we construct a building, we are kind of like accumulating a whole carbon building. You can see this is the carbon material breakdown. So in a building, you have 32% of steel and 22% of concrete, and building services are 20% of that. Associated with carbon, and aluminium, other materials, and glass, and other soft things are considered as this little portion. So you can see that that peak is consistent with all these material associated with the carbon. And then when it comes to during the operation, we have the operation carbon emissions. And if we reuse the building, or when it comes to a time like after 25 years, if you have to do a major refurbishment, do the major refurbishment rather than demolishing the building and building a new one. So the replacement and refurbishment is a way to reduce the whole life carbon emission. And once it comes to the point that we no longer energy efficient or sustainable to run the building, we can demolish the building. But when we are disposing the steel, or when we are disposing the building elements, we have to consider how we can reuse the material so that we can go back and reuse it and limit the waste. So we are doing the same thing for the existing buildings. And so this is a kind of a little chart which shows the operational carbon breakdown. So the structures and the operations are kind of large part of that whole life carbon assessment. So when we do the building designs and consider the net zero pathways, we always consider these aspects as well. So that's why I mentioned it's not only electrical, it's not only mechanical, it's not only hydraulics, not only building services, civil, structural, everyone is considering the net zero pathways when we are building the developing projects and infrastructure throughout the country. So this is another way which I can explain how the embodied carbon and operational carbons, and how we can how we can meet the net zero carbon targets. So when you consider a building, as I said, the building has embodied carbon because of the steel structures, services, and all those things. And when we use the heating, cooling, cooking, and everything, there's operation carbon footprint. And when we introduce operational, on-site renewables and use energy efficient systems and new technologies, we can reduce that operational carbon to a greater level. And when we do the grid decarbonization throughout, like when we go through the years, we can see that the operational carbon emission can be reduced to a very good level, but you still have the embodied carbon within the building. And when it comes, like when we use the recycle the buildings, or refurbish the building and reuse the building as much as possible, if we build less, if we build clever, build efficiently, and minimize the waste, we can reduce the embodied carbon footprint as well. And then at the end, you are right, kind of meeting the zero carbon emission from a building. So that transformation and how we are meeting these carbon reduction footprints and things like that is very very interesting and very important to understand as building designers. So we generally, when we do the building designs, we are doing the ESD assessment, use ESD assessment tools as well. So the environmental sustainability design assessment tools. So mostly we use the Green Building Council, Green Star requirements, neighbors and WELL standards, and we consider basics, etc. for the planning and infrastructure projects. I really don't have much idea about the environmental development and these three different tools, but definitely these three and plus basics is very important, and we are really considering those in our building designs. So the Green Star ratings, we used to have Green Star rating from 1 to 6 previously, but recently with the new latest upgrades, they have removed the 1 to 3 Green Star ratings and implemented this legal compliance, which is the building is compliant with the legislation level. And then 4-star Green Star is the star rated building is a best practice environmental performance. And if you are targeting 5-star Green Star, that's considered to be an Australian excellence demonstrator, and 6-star green is world like showcasing world leadership. So, but with this one, it's with the new Green Star tools, it's hard to achieve 6-star Green Star unless you're very unless the building owners or the developers are ready to spend a lot of money to implement these Green Star requirements. But most of the time, as a minimum 4-star new building, 5-star is mostly we try to rate. And with the refurbishment buildings, 4-star is the kind of minimum at the moment. So the Green Star is accessing a lot of different system standards for healthy, resilient, positive buildings and places, and reducing the impact of climate changes and access like technically it thinks about all 17 UN SDGs. So the this WELL building standard is kind of like focusing mainly on the impact on health and well-being of people. So this is like we used to consider these for healthcare buildings and aged care healthcare buildings, but now we are kind of like mostly going through almost all the buildings, because it's simple. It's not only healthcare aged care facilities, because air quality, water quality, light, fitness, comfort, mind, all these things are important for humans' health and well-being. So when you're designing the buildings for people, so considering well building standards is something which you really have to think about and implement within buildings. So we started to looking at these WELL standard requirements more in current designs. And neighbors rating is another very important rating sustainability development tools, but this is basically mostly for the commercial and mixed use development. So the in these ratings they have separate neighbors energy, neighbors water, and environment and waste. This climate active carbon neutral certification is something which they have introduced pretty recently, which goes beyond the standards energy, water, indoor environments waste ratings, which they're trying to look for full carbon neutrality for their buildings through recognizing carbon emissions from the energy used to power buildings and other sources of carbon emissions. Say, for example, existing buildings, they are trying to remove the boiler systems for heating and implement heat pumps, and introducing EV charging and things like that is always in discussions now. So the clients take the ownership most of the times, and they are like with the help from the consultant engineers, they are driving towards this pathway. So finally, for the electrification of buildings, so we, if you consider a building, we use gas for hot water system, we use gas for space heating, we use, like if it is a hospital building, for CSSD steam, so we are using steam and autoclaves and things like that for most of the gas boilers, and we use gas for cooking and other things. So when, as I mentioned, like we are trying to remove gas from the buildings, but implement this. So say for example, when we were doing the Powerhouse project, we had those retail residencies with food tenancies. So some of the food tenancies, they really want to have the gas cooking, otherwise they can't really make their cuisines. So what we have implemented in that building is we removed gas from all these things, but left the bottled gas connections for those tenancies, which they really need gas. So likewise, we are kind of like going through, it was designed 2-3 years ago. So we are trying really hard to meet these no gas connections for the new buildings, and most of the clients are really like, we kind of like the Arab, as a whole, we always try to drive that initiative, sustainability design initiatives within our clients most of the times. So sorry. Yeah, so as I mentioned, we are using gas for space heating, electric hot water, electric vehicle charging, electric cooking, on-site power generation. So when we think about the electrification of buildings, so this is a diagram which we can implement as a whole, but we don't usually add everything to the building, because that sometimes really push our maximum demand and power load requirements for the building. So we with very careful designs and considerations to existing infrastructure, we always design the buildings to cater for the project requirements, whilst trying to implement the best sustainability design requirements. So this is an example of one of my projects, which we have implemented the roof-mounted PV cells, and with the and also with the mechanical systems. We had air heat pumps and water-cooled combination of air heat pumps as well as water-cooled chillers and cooling towers. So with the water-cooled chillers and cooling towers, it's providing the cooling and the 40% cooling, and this is kind of a polyvalent system which can provide both cooling and heating, and heat pumps purely provide the heating. Sorry, the air heat pumps are providing both cooling and heating, partial cooling and heating, and the chillers, water-cooled chillers, just providing cooling. So and it kind of like assisted with the cooling towers and help us to provide hot water supplies for WCs and non-portable water supplies. So this is something which we have implemented in one of our projects. And this is so we have done a lot of research and assessments of what we can benefit, how we can benefit by using gas boilers and changing it to heat pumps and polyvalent pumps. What are the pros and cons, and how we can mitigate those things. So with the gas boilers, that's the standard designs for most of the buildings, because we have done that for 100+ years, and it's lower spatial requirements and fewer emissions before 2030, because when we consider the gas and power emissions, the currently gas carbon emission is much lower than the electric grid powered gas, carbon dioxide emissions. So that's why we are saying fewer emissions before 2030 without considerations of green power, and less space requirements and things like that. And then when it's come to the polyvalent from, greater energy efficiency, safer than gas, can be offset with on-site or off-site renewables. So with this one, like at this stage, we don't have any commercial or economical commercial benefits, or the capex and opex both are kind of much higher than the traditional systems, but still we are when the grid gets greener, and when we go through the path of decarbonization, that really this design is really effective. So that's why even with additional operating and capital cost, the peer clients are like still they want to go ahead with the design. And also there's part of the certification process and other regulations. So when we talk about the electrification of buildings, we have to talk about the hot water systems as well, because currently most of our electric hot water demands are through the gas-fired hot water systems. So we are trying to implement as much as electric storage and instantaneous water heaters together with heat pumps. When you consider the storage water heaters and instantaneous water heaters and heat pumps for hot water domestic hot water heating, the hot water systems, the heat pumps is the most energy efficient. As you can see here in this table, the kilowatt per unit is the heat pumps is much less than the others, because but only drawback with that is you're having a large heat pump somewhere in the basement or something, and then you have to run the hot water throughout the building to reach each of the level. So that dead leg until like the time which you have to spend until after you open the tap, you have to wait for a couple of minutes or like a few seconds to actually get the hot water. So that's not ideal for some of the installations. So like that's why we are kind of implementing some of like the few different options within a building. So with this project, you can see the end of trip facilities. We have incorporated this heat pump systems, but the other areas we implemented the instantaneous hot water system where they can get hot water instantaneously within few seconds. And EV charging, again, it's something which we are really considering implementing. As I mentioned earlier, that the electric vehicles are kind of increasing. So we are providing the infrastructure for people to encourage people to buy more electric vehicles. It's important to have develop those infrastructure now, so so that we can encourage people. So it's in order to do that, like we are currently in most of the buildings which we are currently designing, we are incorporating these electric vehicles. And unfortunately we don't have a like strict rule which says that you need to have this many car spaces with electric charging at the moment. But the Green Star building standard, they recommend 55% of car parking spaces to have EV charging. But most of the times we are trying to implement about 10% of the spaces with EV charging and implementing a charging management system within the vehicle charging system, so that we can control the power load. Because in my next slide I'll show you that the charging systems need a lot more power than what we expect. So there's three main levels of charging systems. The slow charging, which only draw power 3 kilowatt to 6 kilowatt, which is not a lot. So we can generally use at home, like but the thing is you have to charge overnight. It's 6 to 12 hours to fully charge the car. So but you can use the household standard 10 amps outlet, so which is really good, but you need to have patience until it charge. So and the second type is fast level 2 charging stations, 7 kilowatt to 22 kilowatts. Like it, even though this says 7 kilowatts, usually these are around 20 kilowatt systems, 3-phase mostly. And so these are the medium stay locations, car parks, workplaces, supermarkets, which you don't really want to like it's 1 to 6 hours, again, not 6 to, like they're not very long hours. So but it's again AC, like mostly untethered, which means like you can use the standard plugs and different connections, etc. And rapid charging is draws 50 kilowatt plus, mostly 75 kilowatts, which, like, if you think about having 10 rapid charging stations within your development, it's going to be 500 kilowatt requirements, and like you need to have a little substation to provide power for that. And so the short stay the interested locations are motorways, main roads, routes, and commercial premises. So we have recently done a project, the WARF project. We have done some investigations to see how what would be the power requirement to have a electric charging point for a for a big WARF. What do you call it? Oh, that's not coming to my mind, sorry. So the based on that, we need 2000 kilowatt system to have the electric charging for that. So it's not feasible to have like the general lighting and power requirement for that WARF was like around 150 kilowatt, and to implement one vehicle, one charging point for the vessels, it was 2000 kilowatt. So we can't really, and the client wasn't happy or ready to provide that infrastructure to to that WARF. So we didn't really, finally we didn't implement it, but we have allocated space for those in future. If they want to implement that, they still can do it. And so on-site power generation, this is something which is interesting to most of us, because like in Sri Lanka, we have, as a tropical country, we have a lot of opportunities which we can have PV systems within our roofs. So in Australia, we have 3 main different systems, PV systems, which we can install within our premises, grid direct or grid tied PV systems, which we all install within our roof without a Tesla battery adjacent to it. So it's there are some, it's kind of like easy to install, very straightforward connection, but it has drawbacks due to safety, because it's connected to the grid through a import-export meter. If we are not using power, it's kind of like exporting power to the grid. So if there's a mains power shutdown, you can't really use the PV system anymore, because like you have to there's an automatic shutdown system which shut down the inverters, because you don't want to have power feeding into the grid. If someone is working on the grid, there can be some power left, like working on the grid to fix the issue of power failure. We don't want to have power within those network because of the safety reason. So that's something, one of the drawbacks, that we can't really use it as emergency power. But the solution to do that, like we still can implement the later on, if you think that I want to have a battery system, there's a possibility that we can implement it. That's the second type. So grid interactive or grid hybrid with energy storage. So when we have a battery system associated with our PV system, we can use that battery system to store power, and we have the capability to use the power when we need it. Whereas in the grid tied PV systems, you have, if you don't use the power you generate during the time you are it's generating, it's feeding back to the network. You can't save it, or you can't store it to use it during nighttime, where you would come home and use the system. So that's the drawback. So when you install battery system, we can store the power, and also we can use it as an emergency system. The only thing is, at the moment, the batteries is most we have done a lot of analysis to see whether it is economical to have those battery systems. The battery systems are very expensive. So not only for the residential developments, but for we have done analysis for hospital as well. It's not really because the hospitals are 24-hour service developments. They use a lot of power during the daytime as well. So it's more economical to use that power generated rather than storing it and wait for the nighttime activities. So we, but there are, we know that there are some hospital projects which they have installed PV systems with the battery storage, but the one which I did, we haven't really installed any battery systems. It was a 400 kilowatt system. We have assessed the power usage throughout the throughout few years, and it wasn't really economical to implement the battery system in that. And off-grid with energy storage is the third type of system. And with the off-grid systems, it's good for people who live in very rural area without access to the grid-connected power. But if it comes with you don't have to you are the owner of that energy development, but there are a lot of drawbacks with that. Like if you have if it is winter time, no sun, you don't get enough power, and like off-grid systems, PV systems are not really suitable for most of the developments. So apart from that, if those are the main things which we consider considering electrification of buildings. And apart from that, we consider use of LED lighting, electric cooking, steam boilers, high efficiency rated appliances, and use of zero halogen products for cables and conduits, etc. So when we always try to address every bit which we can consider reducing the carbon footprint and the embedded carbon within the building. So I don't know whether we have enough time to go through a few project options.
Bandula, I think we can have another 10 minutes.
Okay, yeah. So I would like to these are some of the projects which I have recently completed and designed as full electric buildings. So this is Powerhouse Project, which I mentioned earlier. It has we have implemented polyvalent heat pumps, chillers, hot water, electric cooking. We have this is the one which we have some sort of gas bottled cooking for the some of the retail food tenancies, and we installed 150 kilowatt. We have designed 500 150 kilowatt PV systems as well. And the one of the hospital jobs which I mentioned is we are installing, it's a 34,000 square meter new hospital with the acute services building and major refurbishment of existing building. And we are introducing all these, that hospital is going to be the first New South Wales full electric building from day one. And so this, like, I would like to go through a bit more about that hospital development, which I mentioned. So we are aiming to get 5-star Green Star self-certified design and built ratings for the new acute services building. And the refurbishment building will only get the 4-star Green Star requirements. And we are considering well building standards for all both of these buildings. So when we consider refurbishment of existing building as well as the new building design, these are the main things which we usually consider, like the human-centered design, which is mostly associated with the WELL standard, the considering natural lighting paired with comfortable glare-free lighting design. And when we select the light fittings, we have we select higher CRI, color rendering index light fittings, and use tunable luminaires that emit light in harmony with body circadian rhythms. So some of the areas, like the implementing body circadian rhythm in lighting design, is bit expensive, so we usually select some particular areas for those things. And lighting controls with integrated daylight controls, and so we use this human-centered design principles to when we are doing the building services designs for buildings. And then net zero circular economy and electrification is another area which we usually use. How we are implementing those is use of low halogen materials, electric heating, electric hot water, and electric vehicle charging, CSSDs with gas-fired equipment, like replace the electric equipment to with the gas-fired equipment to replace, electric equipment to replace gas-fired equipment. And refurbishment areas, we have access to reuse the existing infrastructure wherever possible, and reuse them by just modifying it rather than doing a full high-level refurbishments. And green energy PV, like within this hospital, we have implemented 400 kilowatt PV system within the existing building, existing hospital buildings, because usually with the hospital buildings are single or double story buildings in most of the rural areas. But now we are the acute services building, which we are designing for this building, this hospital, is 7-story building. But the existing building only is 2-story, but it has a lot of opportunities to implement PV systems. So we have discussed with the health infrastructure and the builders and project managers to implement this PV system. And we have like, it's currently actually they're installing it at the moment. And also we always consider the climate changes and the resilience to the climate changes. And so with if it is within a flood level, all major electrical infrastructure need to be located about 100 flood levels. So as per the the Power Supply Authority standard requirements, all substations need to install with above 1 to 100 flood levels. But in addition to that, we always try to put our major infrastructure, including the main switchboards, etc., and generators above this flood level as well, so that we can ensure the resilience of the services. And recently we started having these pandemic considerations and considerations and infectious controls within the buildings, and through the air conditioning systems and switches and all those things. So this is again like this is an example project and details which we have done. So I think I mentioned that currently the gas emission of carbon dioxide emission within gas is much more than the electricity scope 2 emission. So that's why we have done the assessment of using gas and electric pumping energy and electric energy using like two different options, all electric and the traditional method, to see what would be the emission factors and how we can factorize the effect of carbon dioxide emission. So until 2030, we won't be able to meet the carbon neutrality requirements with the introducing electric, but we don't want to implement something else and develops another system after 10 years. So that's why we are aiming to install the building as all electric from day one. And this is a cost analysis of operational carbon and capex and opex cost. So the capital cost, like we have calculated using all mechanical, hydraulics, electrical considerations. We have considered compared the traditional and all electric considerations, and again it came up that the capex and opex cost much higher in all electric buildings than the traditional. But again, with the initiatives and the clients' drives towards these sustainability design development strategies, we are still implementing these sustainability initiative strategies within buildings. Yeah. And this is the 400 kilowatt PV system we have installed. We are currently installing in the existing hospital. So this is a diagram of the maximum demand records of that facility for that year. What we have done, like when we are sizing the PV system, we have tried to stay below this is only one of the main switchboards. So this hospital has two main switchboards, and it's kind of divided into two separate. So we within this one, you can see the maximum, the average kVA is 225. So the amount of PV generated power connected to this one is less than 200 kilowatts. So that there's an aspiration from the health infrastructure to maintain the zero export principle. So in order to maintain that, we try to minimize the export. And we need to run the facility anyway to see whether we are utilizing all the power, because it's designed, if there's any additional power, it will export to the grid. But still, we since the generated power is less than the base average maximum demand, we would expect that the power generated would be utilized within the hospital. Yeah, that's it. If there's any questions, feel free to ask. I hope you all enjoy the presentation.
Thanks a lot, Bandala. Yeah, we will wait for some questions from the audience, but there's a question from online posted by Nihal Fernando. So he has asked a question. Businesses are going green for many reasons, in addition to social responsibility. Will there be real commercial benefit schemes like carbon trading in Australia in the future?
Yes, so yeah, definitely. It's like in addition to the social responsibilities, when you design the building, to incorporate like when you're designing an energy efficient building, you pay less bills, and you are providing benefits for the occupants through the design, like providing a comfortable environment. So it's not only the raw social responsibility, it's providing much more than that. Like if you look at that UN SDGs, it's not only the social benefits, it has like commercial benefits and much more than that. When the main one of the main reasons for most of the building owners now trying to reach the neighbors ratings and other ratings, because they believe, and there's an actual recognition from the community, that if you are running a building energy efficiently, that you are kind of doing that's the goodwill, like that's kind of like commercial benefit. Like it's not direct commercial benefit, but when you have a like really interesting building with like energy efficient building, you will attract tenants, you will get commercial benefits through that. Is that explained well, Nihal?
Yeah, Bandura, I think yes, that means the there are many, there are many benefits. You know, that means I think it is still going as kind of social responsibility. Yeah, that means that you get the acceptance from the community and so on. The I think probably the other reason, of course, you explained that mean there will be some regulatory requirements as well. That means you must, you know, that comply with the. Yeah. But is there any, that means my question was, that means, yeah, is there any like, you know, carbon trading or you know, similar scheme that means when you are reducing your carbon footprint, that means there should be some sort of measurement and then you are getting paid off the you know, in carbon trading. Yeah. I'm just thinking.
So to answer to that, Nihal, there are some like the our buildings are not at the moment, because of the grid is not decarbonized. Our buildings and the whole systems are not at the level which we are producing negative carbon footprint. So like positive carbon footprint, so that we negative carbon footprint it should be. So that means we are not developing a project which we can trade the carbon. But say for example, with the Powerhouse, what we propose to them is, because we had only limited capabilities to install a PV system within that, we have asked them to get in contact with one of the PV, like the PV solar farms which we have in Canberra and different rural areas. So what they can do is they can, it's kind of like again carbon trading. So they can get in contacts, like the contract, get into contract with the to purchase those green energy and utilize those. And implement, like meeting the carbon footprint targets which we have to achieve within the building. So there are different scenarios which we are doing. And also I know that in USA they have like much more developed green energy farms and a lot of new installations going through. But we just started with these solar farms, etc. So we are not really generating a lot of green power at the moment, but we would expect that would be significantly change in future.
Right. Yeah. Thank you.
Thanks. I think there's another question at the top. Hi, Pradeep Dankar, who is presenting working for this year. Oh, no, that's a question. And I saw Amaliaka in the meeting. Mariaka, do you want to say something about the decarbonization and like the plans within the national, like within Endeavour Energy?
Hello, Bandula and everyone.
Hi.
Thank you. Great presentation. Very well done.
Thanks.
It's a lot of information to digest. Look, I'm not nowhere near expert to talk about any of the. I know our organization has very high level commitments for the reduction of carbon emissions in every area, but it's a very high level plan at the moment. So we haven't gone into the details yet to present to the communities yet.
Okay.
So in the near future, you'll probably see what are the
Thank you.
initiatives we have taken. I think building
Exactly.
services sector is well ahead, and the electricity utilities, as I can see with your presentation.
Thank you. And there's a question from Jagat here. Great. I think Sri Lankans are keen on domestic solar power to sustain power failures. Can you advise what system would be the best suit, considering solar panels to generate electricity? So the grid-tied system is the probably one of the good ways, considering the cost of battery storage. But again, when there's a power failure, we won't be able to use it. So it won't be a solution for sustaining power failure. So if we are installing PV systems, it would be more beneficial to have some sort of battery system to store power to use when it's not, like when you have when there's a power failure. Do you need more explanation, Jagat?
Looks
Yeah,
they are
I
silent.
answered that question, and I think a lot of our Sri Lankan community they were really keen on investment and some sort of development for people to buy solar home-based solar generation systems. So I think you may help those communities, if possible, with some know-how how to develop a good system for the local market. Yeah, thank you.
Yeah, definitely. I'm happy to help with Jagat. Please reach out to ISL New South Wales chapter. You can get in contact with me, and also like with like I can propose something like in Australia we are aiming to develop something called area-based battery system, the community battery systems. Maybe something which, like if we can get together with like 10 different households around area, like within a certain development area, what you can do is like you can get together and connect like install a community battery system, which you like all the power generated through the PV systems from each of the households will store, like if it is not used, it will store in the battery system. And commonly they can use the when they need power from the battery system, they can extract power from it. So the community battery systems are implementing in New South Wales at the moment as well. So yeah, I'm really happy to help with developing such strategies if you're keen.
All right.
Yeah, I'm happy to share the presentation. I'll send it to Soti so that you can distribute it to the people who want it.
Yeah, definitely we will do that. And there are other comments from Vasanta and Vijayanaika, Shanta, Donald, and Nihal Fernando. Okay, appreciating your presentation.
Yeah, I can see that.
Everyone said it's very well done.
Thank you. Yeah, thanks. It means a lot to me.
Okay. Any
and
other questions
thank you everyone for joining today. Like so that about 60 plus representatives joined today. So yeah, I'm really happy to have you all here.
Not only you, I am very happy too. All right. Okay. So now, before just giving the doing the vote of thanks, all the audience, please register with the IESL NSW chapter, which is on the online stuff. So if you register with this one, you will be able to receive our flyers and the presentations coming up. So we extremely encourage you to participate in this lecture series, which are very useful. All the expert engineers and academics comes from our Sydney area and worldwide to do these presentations. We encourage you to participate. That will be a great thing for our professional development and for the community. While thanking Bandula, let me call upon Manasi Vijayaratna, our secretary, engineer, Dr. Manasi Vijayaratna, Dr. Manasi Vijayaratna, to give vote of thanks on our behalf of IESL New South Wales chapter.
Thank you, Soti. Good evening, Engineer Bandula Subasinghe, IESL NSW Chair, ladies and gentlemen. It's a great honor and privilege to propose the vote of thanks on this occasion on behalf of IESL NSW chapter. Let me first and foremost thank our distinguished presenter, Engineer Bandula Subasinghe, for delivering this informative and interesting presentation. We are grateful for the time and effort you took to share your knowledge and experience with us. Secondly, I take this opportunity to thank Engineer Asika Gunawardana, who took the initiative to coordinate with Engineer Bandula to arrange this event. I would also like to express our sincere gratitude to Mr. Chamila Priyantha from IESL headquarters and Engineer Buddhi Vijayaratna from IESL NSW chapter for organizing the all technology-based logistics on the background. Next, I would like to thank our wonderful audience for your presence and your valuable questions. Last but not least, I thank the committee members of IESL NSW chapter for your cooperation in making this event a resounding success. Looking forward to see you all at our next IESL event. Good night and enjoy your evening.
Okay, thank you everyone. The Zoom platform will be open for another maybe about 10 minutes. Whoever want to have a chat with your colleagues or with the presenter, still you are open to do that. Have you seen any of your batchmates here, Bandula? Manasi?
Yeah, I didn't know. Maybe you can talk to me if anyone joined.
I saw hi, sorry, Nihal.
Yeah, Nihal, yes.
So today's participants, that means, did we have many from Sri Lanka?
Yes, I think everyone is from Sri Lanka. Only we from our side, and myself, you, and Siti is here, and I saw Rohida as well. Okay. But all others have out of we had one time we had about 78. So
yeah, that's right.
Yeah, all were from Sri Lanka. Yeah, greatly appreciated the Sri Lankan participants.
Yeah, definitely.
Yeah.
It's I think a timely presentation we had it because the power crisis going on there. Okay, so I think that's what some of the people put the comment as well. Yeah.
Yeah, if I know that like that much of Sri Lankan participation, I probably will put more put more information related to Sri Lankan standard requirements. But like I'm kind of like out of touch with the Sri Lankan building design developments.
Yeah. But still, I think the PV system was very curious to know by people how we can electrify the Sri Lankan household.
Yeah.
So that's what they were ringing around with the questions. So I think we need to do something, okay, which can reduce effectively, okay, by having a PV system, effectively we can reduce the household electrical power load. So we can use most of the things in the daytime while the energy is being produced.
Yeah.
One of my batchmates is into this one of this business. We're doing solar panels and solar heating stuffs.
Yeah.
Okay. But they are extremely costly. That's the problem because of the dollar to rupee value and
Yeah, that's the thing. And like when even in Australia, if you are putting a battery system, you have to pay like if you install the PV system for $6,000, you have to spend another $10,000 on top of that to install a battery system. So that's why we don't see much battery systems in Australia, but we have like more reliable network than Sri Lanka. So we can survive without a battery mostly. But in Sri Lankan situation, I guess situation in Sri Lanka, I guess it's better to have the battery system which you can utilize those generated power, and you probably will generate a lot of power with the amount of sun we are getting in Sri Lanka.
very true. Yeah. I have heard in rural NSW, there are some people, they want to get rid of the electricity main connection and they want to be totally on
the off-grid systems. Yeah, but the thing is they need to have like one or two other energy sources within them, like either wind system or generator with them, because you can't really totally in Australia, like some days we have like some weeks we have few days without any energy, like any sun, it's very dark, and then so it's so hard to solely depend on the solar systems. You need to have like if you are ready to live few hours or a couple of days without power, then that should be fine. Otherwise you have to have a small generator in your backyard.
Yeah. Also, I don't know, this probably you know much better than me. They have a electric car system which can work as a battery storage and kind of thing. This is the research. Maybe you are the one told us. So I heard somewhere, I'm not too sure. So that car works as a battery system as well as a car.
Yeah, so like almost all the electric vehicles, you have the capability, but you have to do a bit of changes to the electrical infrastructure. You can use those as during the time where you're charging, you can use it. You're charging from the household power connection. At the same time, you can use that battery system to power the house. Like it's two-way always, but you need to do some modifications.
One of the companies coming out that's so very attractive. So you are getting something like paying about 70,000 or 80,000 for a car plus battery system.
Okay.
Then hopefully those things will come. It will be very attractive for Sri Lanka, definitely, because 70, 80 for the car prices, what they are paying, okay, it's cheaper to pay that kind of buy that kind of car.
Yeah. And I think that Dante posted the question here, right? There are over 30,000 household PV installation in Sri Lanka now. There's a major problem with financial model in Sri Lanka. CEB has to purchase solar energy at a higher price and sell at a that's different in like in Australia, we have to export power at higher cost, and we buy lower cost, and we buy power at higher cost. And in Sri Lanka, CB is purchasing solar energy at higher price and selling at lower price. I don't know that, like, why is that correct?
Sorry.
I think he's
All right.
he's not.
Okay. Okay. So let's finish it up because there's another meeting coming up for Colombo people. So they have to use this platform for another meeting. So we have to wind up our meeting.
Oh, okay. All right.
Okay.
Thank you everyone for joining today.
Thank you.
Thanks,
Okay.
Odi.
Thanks, everyone.
Manasi.
Thank you.
Bye.
Thank you. Bye-bye.
Bye.
Bye.